Okay, I think in the previous tutorial we have seen how we can spawn our workers, but currently if you look at the workers spawning, they have spawned on the map, but they are not moving towards a resource, or they are not doing any sort of task, right? So let's try to do those AI related interactions uh, from this tutorial onwards, right? So basically we will do quite a lot of AI character handling, and yeah, I'll try to keep things as simple as possible. Great. So let's first start by creating a specific AI controller for our workers or characters in the other sense. Um, so maybe there is our BP worker under the characters and the workers. This is the base class for a worker, right? Okay, so I'll close the other tabs, and yeah, so this is the worker. And if you look at the AI controller of this class, is just the default AI controller instance in the Unreal Engine, right? So we don't need to actually use this controller. Instead, actually we want our own AI controller. So how we can do that? Basically, let's first create a folder called AI. So all the AI related logic I'll create over here, right? So we will be having a proper folder structure there. And in the blueprint class, let's search for AI controller, and I'll use a detour crowd AI controller. So this is parent class of this generic AI controller with some additional functionalities. But if you don't want to use the detour crowd controlling, instead of that you can use AI controller as well. But I think this detour crowd AI controller is much better by handling these sort of AI characters. So let's use that, and I'll name this as BP worker AI controller. Okay, then actually let's check event process function, event on process, and let's try to print hello, or maybe let's try to print the processed form. And let's assign this AI controller to our worker base, which is this thing, and let's try to simulate it again. Okay, maybe let's simply print hello world. Okay, yeah, so the auto process AI should be not only the placed in the world, but also should be placed in the world or spawn. Otherwise, actually, when we are dynamically spawning our worker classes, they are not inheriting the AI controller classes by default. That's why actually we need to spawn it like this. So make sure to keep this as placed in the world or spawn. Okay, now it should work. Okay, now it's printing hello world, and maybe let's try to print the opposite spawn as well. Okay, so minor number farm. So everyone is processing the AI controller now instead of using the default AI controller. Okay, then actually actually we need to create a behavior tree as well to control the AI created functionalities. So let's try to go to the artificial intelligence and create a behavior tree, and I'll name this as BT worker. Okay, then actually we need to create a Blackboard instance as well to store the variables related to AIs. So BB worker. Okay, and by default we have a self actor, and Blackboard asset, it should be BB worker, and we need to assign, or we need to link this behavior tree to our worker AI controller. So instead of printing, now let's try to run a behavior tree which is BT worker. But currently there is no behavior, so maybe let's try to add random walking state maybe. So I'll maybe maybe I'll simply create a task first, right? New task, and actually I'll create another folder called task, and let's rename this as btt random, or maybe let's say wandering. Okay, okay, then let's go to the task, and actually event receive execute AI, and for each AI we need to actually promote this to a variable. So maybe first I will try to use the event receive execute AI, so it will execute only once. The tick AI is calling actually all the time, but yeah, for now I think this would be fine. So let's use the tick AI, and let's first check whether this is valid or not. So what I'm going to do is basically move our workers in the map for some random locations, right? And I have to cast for the worker base, and let's promote it to a variable as well, worker ref, and if it is not casting correctly, actually we have to finish execute, and it is not success. Also let's try to move our AI, right? And this is the phone, and we need a destination, so maybe let's promote it to a variable called target location, and expect acceptance radius, maybe I'll make it as 50, and stop on overlap, and if it is succeeded, we can finish the execution by saying it is success, else maybe by waiting some random delay of 0.5 second maybe. If it is failed, we can inform our AI controller it is a failure, and we need to set this target location as well. So let's set target location over here, So I'll get random reachable point in radius, and the origin should be our worker reference actor location, and the radius I'll maybe make this as instant editable, and let's search for 2000 radius, and yeah, it should give a random location over here, and it should move to this specific random location. And let's go to the behavior tree, and I'll add a selector for now, but it won't do anything yet. And let's add a sequence as well. Let's say if we wanted to perform a specific set of actions, we can use this sequence. So maybe I'll wait for 5 seconds with random deviation of 2, so it can be from minimum 3 seconds to the 7 seconds waiting time. And once it was exceeded, I can execute BTT wandering task. So it will basically move our AI character for a random location. Okay, so I can actually play right now, but you will see nothing works, right? So they will respond, but they won't move. But if you look at the BTT worker or behavior tree, actually it's waiting for random seconds, and actually it's, have you seen that they are moving to this specific action, but they are not moving, right? So actually I'll disable these two buildings right now, so it will be easy for us to debug. So the issue was actually we haven't placed a nav mesh volume or nav mesh bounding volume to our map. So let's place this thing. Actually what this nav mesh bound volume do is it sends the landscape and give a random position or random location for these sort of AI behaviors, right? So let's I have placed an instance in the map, and you can actually press P on your keyboard, so it will show you the the reachable radius or reachable ground on your map. So this is a small area, but we need a larger area, so I'll increase its size, something like that, and yeah, like this. And maybe I have to increase the C depth as well. Okay, now I think it covers almost all the range. And yeah, let's see it again. Right, so let's try to simulate it. Okay, maybe first I'll disable this thing again by pressing P key again. Let's go over here, let's try to play. Okay, they are spawning. Yep, they are moving, and the animations are properly playing as well. Yeah, but I think maybe I can go to the worker base, or maybe I can go to the character base. and let's try to reduce the movement speed a little bit, because I think they are moving like really fast. So maybe let's take a look at character animation graph idle walk cycles. What's the threshold value that I put there? Okay, it's 200, right? So in the 200 it should be proper speed and playing properly, animations properly. So in the there should be thing called max walk speed. Okay, here let's make it 200 and compile and save. Let's try to simulate it again. Okay, number has been spawned. Wait, okay, now it moved to the random position. Yeah, wait, random time, and again move to some random position. Great. So let's enable other workers as well. Let's make it active here. Let's try to simulate. Okay, number is there, farmer girl also there, and yeah, she moves. So where is our miner? Okay, miner is also moving, and there is a lumber. Okay, lumber is also moving. So all the characters are moving, but currently they are moving random locations, like, which is not the ideal case that we want. We need to actually move them towards to the resources, and maybe going back to their home resource building, something like that. But those complex transitions may need some state management as well, some sort of context switching between multiple different states. So let's do that in the next tutorial, and I'll see you there. So thank you.